Welcome back. This is Mrs. Rubright with Advanced Geometry. Today's lesson is 6-3, Prove Triangle Similar by Angleangle. Copy of the for-your notebook on page 375, and then press play. You can pause the video now. Alright, so determine whether the triangles are similar. If they are, write a similarity statement. Explain your reasoning. Alright, so angle-angle similarity, right? So as long as their angles are all congruent, if their angles are congruent, then the triangles are similar, right? So if you have a 30, 60, 90, they are proportional. They are similar no matter what. Because you could have a small one or a large one, but they will always be proportional as long as they have the same angle measures. So looking here, if this is 90, 180 minus 90 is 90. 90 minus 26, what is 90 minus 26? 64. So now that we know that this is 64, we have angle, similarity. If two angles are the same, then we know obviously third angle theorem, their third angles are the same. That's why we don't care about the third angle. So by angle similarity, these two triangles must be proportional. They must be similar. Make sense? All right, so show that the two triangles are similar. So show that the two triangles are similar. Triangle ABE and triangle ACD. ABE. So, do you guys see how they both have a 52 degrees? Correct? Do you guys see how this angle up here is the same angle in both of them? Reflexive, right? Same thing equaling the same thing. So angle EAB is congruent to angle DAB because it's the same angle. So by angle similarity, these two triangles are similar. All right, over here, we have vertical angles, right? Vertical angles are congruent. Do you guys see how these are parallel? What else do I know? Because they're parallel, I know what? What else do I know, guys? Alternate interior angles. We know that angle U is congruent to angle S. So now by angle similarity, these two are similar. Make sense? Okay, so showing that. Show that the triangles are similar, write a similarity statement. So if this is equiangular, therefore it's equilateral, right? This is an equilateral triangle. Equiangular. If they are all, both of these are 60, 60, 60, right? So they have to be proportional, right? All equilateral triangles are going to be proportional. They're going to be similar. Right? These are all 60, so 60 and 60, 60 and 60. By angle similarity, they are proportional. They are similar. So that the triangles are similar. Okay, well, if this is 90, this is 90, so we know that they have that. 180 minus 90 is 90. 90 minus 32. 58, right? Now these angles are the same. So by angle similarity, they are proportional. They are similar. A flagpole casts a shadow that is 50 feet long. At the same time, a woman standing nearby who is 5 feet 4 inches tall casts a shadow that is 40 inches long. How tall is the flagpole to the nearest foot? Okay, so her shadow is 40 inches. And her height is 5 feet 4 inches. Turn that into inches, right? Because we have to have the same measurement. So 5 feet 4 inches. How many inches are in 5 feet? 5 feet, add a feet, and into inches. There are 12 inches in 1 foot because the feet are diagonal. You cancel them out. 5 times 12 is 60, so 60 inches, plus the 4, right? 5 foot 4. So she's 64 inches tall. All right, so now the flagpole. How tall is the flagpole? If its shadow is, how much is its shadow? The shadow is 50 feet long. Well, how many? 50 feet. Add a feet. They have to be diagonal. And into inches. 1 foot is 12 inches. So 50 times 12. What is 50 times 12? If 5 times 12 was 60, isn't it just a 60 with an extra 0? 600? All right, so we're looking for this. So 64 is to what as 40 is to 600? Cancel out those O's. 4 goes in here. 2 goes in here. Well, 4 goes in there, right? 30, 15. So 1 and 15. So 15 times 64. So what is 15 times 64? $960. Good. So this is 960 inches, but we want our answer in feet. 960 inches. We need to get out of inches and back into feet. So they have to be diagonal to cancel out. There's 12 inches in 1 foot, so we're just dividing by 12. And we get 80. It is 80 feet tall. Does this make sense, guys? Have to have the same units and then set up your proportion, cross products, and solve. You're standing in your backyard, and you measure the length of the shadows cast by both you and a tree. Write a proportion showing how you could find the height of the tree. All right, well, how would you find the height of the tree? So there's you and your shadow. There's the tree and the tree shadow, right? So your height is to the tree's height as your shadow is to the tree's shadow. Or your height is to your shadow as the tree's height is to the tree's shadow, right? There's different ways to set it up. As long as you're staying consistent, it will work. So the tree's height to your height is the length of the tree's shadow to your shadow, right? Tree's height to your height, tree's shadow to your shadow. Tree, you, right? You, tree, either way. And that is everything on today's lesson, which was 6.3, Prove Triangle Similar by Angleangle. Angle, Similarity. I hope you guys enjoyed today's lesson. Please like and subscribe and have a wonderful day.